Alright, in this video we will talk about horizontal asymptotes. Basically, this is another imaginary line used to aid in graphing rational functions. Alright, so it's horizontal, so it looks like this, kind of something like that, and we keep it dotted, right? But basically, as x approaches far to the left, as your x values go far to the left, or negative infinity, some function will approach this line like this, okay? Something like that. As you go far to the right, then maybe the rational function will approach that line again. That's what horizontal asymptotes are. They're the line that the function approaches over time to the, from negative inputs to positive inputs, way to negative infinity to positive infinity. Now, horizontal asymptotes may be crossed, okay? This is the difference between a vertical and horizontal. In the vertical, you can't put the number in, so it never even crosses it. But here, it could cross the horizontal asymptote, so you might get something like this. But probably if it crosses it, it's going to come back towards the horizontal asymptote. Okay? So here are my three functions, f1, f2, f3. We saw in f1 in the previous video that there's a vertical asymptote x equals 3. The horizontal asymptote is a little different. Basically, we say, let the x go to infinity and see what this thing approaches. All right? Well, it's hard to see that right now, especially if you're not into calculus. So basically, we have some rules that we look at. Okay? So the rules are, if the power or degree of the polynomial here, so the degree of the numerator polynomial, is the same as the degree of the denominator polynomial, and they are degree 1, right? Then we take the leading coefficients as the horizontal asymptote. So it's a horizontal, so y equals 2 is the leading number 2 over 1. So my horizontal asymptote for f1 is 2. So let's look at that. Here it is 2x minus 1 over x minus 3, and we can see there is a horizontal asymptote at y equals 2 right there. All right, let's look at the graph. I put negative 50 in because that's a very small number, right, for the x. And look what number the output is almost, 2. And as I go to the right here, it goes further away, and then it starts following this, right? So it gets further and further away from 2 until you're on the other side of that vertical asymptote. Especially right on the other side there, it starts up really high. Okay, 10 starts up at 2 something, 2.7, but it comes down, and over time, as we get bigger and bigger for the x value, it gets closer to 2 again. And that's what's going to happen. So as we go left forever to negative infinity, it gets closer to 2 for the output, and as we go right to positive infinity, the output gets closer and closer to 2. So there is a horizontal asymptote right at y equals 2 for this graph. That occurs, again, when the powers are exactly the same, or when the degree, I should say, of the numerator equals the degree of the denominator. f2, it's a different function. Now the degrees are not the same. Notice, x to the first power, right, and x to squared. When this happens, there is no, when this happens, there is, okay, let's cut that. When this happens, there is a horizontal asymptote at y equals 0. Okay? Because again, when x gets really big and x gets really big, we'll see that the graphs get really close to 0 because this x squared, is going to explode, right? Think of putting in there a million. A million squared is a super big number over just 1,000,003 over whatever that is. It's super big. So we have a very small number. So thus, it goes closer to 0. We'll see that in the graph in a moment. But what I'd like to do is I liken this to basically the graph of 1 over x is how I kind of think of it. Because the graph of 1 over x looks like this, as you will find out in time. And it has a horizontal asymptote at y equals 0. And this one I can remember because the denominator power is bigger than the numerator power, just like this one. Denominator is bigger than the numerator. So let's look at that graph. Here's the graph. You'll notice that there is a horizontal asymptote right here at y equals 0. It's right there, that dotted line, right? It's not part of the graph, but I put it in there just to show you how to graph it. All right, let's look at the x values then. Far to the left, negative 35. Look, it's almost 0. It's a negative 0.026. As we get closer and closer here, we're going to see that, look at, this graph actually crosses this horizontal. Look at, the red crosses the gray, but then comes back to the gray, right? All right, then in between we have this graph here. That doesn't affect the horizontal. This one goes towards these two vertical. And then on the right side over here again, my graph comes back and gets closer and closer to 0. So at 5, look at 30, it's almost 0 again. And you'll see as it goes towards infinite that you'll get closer and closer to 0 to the right and closer to 0 to the left. All right, our third one, x cubed over x squared minus x minus 6. We saw the vertical asymptotes before. Now we're looking at the horizontal. This is the last case. Notice that the degree of the numerator is x cubed, or 3. The degree of the denominator is 2. So numerator is larger than the denominator this time. In this case, there is no horizontal asymptote. Doesn't exist. Something else exists. You might be able to see it. But let's look at this graph. All right, here's this graph. You'll see that there is no horizontal, no lines going, that come flat out towards a horizontal. All right, look at the graph. -8 out here, it's -7. It's down here. It gets closer and closer to here, and then it's undefined, and it gets really, really small again. All right, then on this side, again, it's not going towards any horizontal. What it is doing is going towards this slant, though. So there is a slant asymptote, and you can view the video on slant asymptotes to see when that occurs. But what we're looking at right now is that there is no horizontal asymptote when the denominator is less than the numerator, or the numerator is greater than the denominator, however you want to look at it. Here's the basic summary then. So if n is the degree of the numerator and d is the degree of the denominator, here are our findings. If they're equal to each other, then you just take the leading coefficients, like we did in F1, 2 over 1. If the degree of the numerator is less than that of the denominator, it's the same basically as the graph of 1 over x, where you have a horizontal asymptote at y equals 0. So degree, numerator was less than degree of denominator, we have y equals 0. The third case is that the numerator is actually greater than the denominator, and there is no horizontal asymptote, and then you need to check for slant asymptotes. Next video. All right, what we want to do here is then try a few examples. So here's F4 and F5. All right, look at these and think about what the the horizontal asymptotes of these functions are. So remember, you're comparing powers, and you're comparing powers. So let me maybe move up here. Can I get this in there? Yeah. There you go. There's the directions for comparing these powers and finding the horizontal asymptotes. So do that now and pause the video and then check back with me. Okay, let's find the horizontal asymptotes. F4. The degrees are exactly the same. Second degree, second degree. So we should expect to see a horizontal asymptote at 3 over 1 or 3. We check the graph, we see 1, 2, 3, a horizontal asymptote at y equals 3. We see that as we go to the right infinitely down here, we get closer to 3. As we go to the left infinitely, we get closer to 3. Next one, F5. There, in the numerator, the degree is 0. In the denominator, the degree is 1. Therefore, it's just like the graph 1 over x, basically. So we have a horizontal asymptote at y equals 0. Let's check that one out. Here we see the horizontal asymptote at y equals 0. Again, checking my x inputs. Far to the left, -35 is about 0. As we go to the right, far to the right, 30, it's about 0 again. So the horizontal asymptote is at y equals 0 because the denominator is greater than the numerator, or numerator is less than the denominator, however you want to think about it. So again, in conclusion, here are the rules for this right here. Equal, use leading coefficients. Numerator is less than the denominator, same as the graph of 1 over x, we have a y equals 0. And if the numerator is greater than, we have to check for a slant asymptote, there is no horizontal.